Okay, so let's get on with this discussion because I don't have a lot of time to waste. So let's move on to Newton's. Let me get the red pen. We'll go to Newton's four laws. Whoa, you in the back. I thought Newton had three laws. Well, I know that's what you thought. And the reason you think that is because probably since you were in the junior high public school system, they told you that Newton had three laws of motion. And I suppose if you want to make the statement and say Newton has three laws of motion, well, then if you kind of confine it to that statement like that, well, then maybe you can get away with saying that, okay? However, once you say to yourself that Newton has three basic laws that control what we're trying to learn in statics and dynamics, then you have missed the entire point, and you will never be able to work the problems successfully until you understand that he actually has four laws. Now, the fourth law, people usually talk about it. It's called the law of gravitation, which we'll get to in a minute. Most people are taught that the law of gravitation comes from the Newton's second law. It does not. And some people that I talk with think, well, that's an esoteric point, and why are you wasting time saying that? Well, the reason I'm wasting time saying that is because when you get to 363 and you start trying to work those problems, if you don't have a full comprehension of the fact that there are four independent laws presented by Newton that are independent of themselves, they're not interrelated. I mean, you can make some arguments that there are some interrelations, but Newton's law of gravitation has nothing whatsoever to do with Newton's second law. See, so there, and I was very careful here not to say Newton's four laws of motion. I just said Newton's four laws. And these are the four laws that we use. So let's jump into this. Newton's first law. It says if the resultant force acting on a particle is zero, the particle will remain at rest, if originally at rest, or will move with constant speed in a straight line if originally in motion. Now, my first question is, what's a particle? Well, I don't know. Here it is. There's a particle. It's a dot, okay? Okay, so how'd that get to be a particle? Well, it's really small. And so maybe you can argue that if you got a particle, it's so small that geometry doesn't matter, but maybe the particle possesses mass. So that's kind of what we're saying here. Maybe it does. But the geometry of the thing is such that the behavior of this little dot or this little particle is not dependent upon the geometry. Maybe it's only dependent upon the mass. Well, how small does something have to be a particle? Well, it depends, just like everything else in the world. If you're kind of looking at the solar system and thinking about the Earth rotating around the sun, it's probably okay to say that the Earth is a particle. You know, and as big as the sun is, it's probably okay to say that it's a particle too, because we're many millions of miles away from the sun, so the diameter of the sun with respect to the distance between the sun and the earth is so large that maybe we could say it's a particle and maybe we could say the earth's a particle. So it's kind of a relative term. And it's very hard to define, but it's like, if you think about it a little bit, and you know what I'm talking about. I don't want to beat it to death, but it's a very small thing, primarily defined by mass and a single position. And what I'm telling you is, if this guy is sitting still, and how would we know if it was at rest? See, that's the $64 question. How would we know the particle is at rest? Well, the only way we could know that is if we had a reference frame that was not accelerating. And we've already been over this. Where do you go to find a non-accelerating reference frame? Well, nowhere that we know, but we have conceded that if we are on the surface of the Earth and I attach a reference frame to that is good enough for most of the problems that we work. And so if the particle is at rest with respect to a reference frame on the surface of the Earth, it stays at rest. If it's going in a straight line at constant speed, it'll just keep going at a constant speed. So that's what Newton's law, or Newton's first law, says. It's as simple as that.